Hi everyone, you're welcome to today's lesson in mathematics, and our topic for today is place value of decimal numbers. The place value of decimal numbers. Last week we considered the place value of whole numbers, and we looked at a similar number chart as the one we have on the board. But there we had a unit as the one with the least value, and we worked from that unit end, which is to the extreme right, and we worked towards the left till we got to the position of million where we stopped, units of million. Okay, and in that lesson we said that the unit had the least value for whole numbers. So, but today we're going to look at the place value of decimal numbers, and we're going to find out that beyond unit to the right, there are numbers, but these numbers are not whole numbers. These numbers are not whole numbers, they are fractions. Fraction means they are not complete, they are not whole. Okay? So these are the ones we're going to look at today, and these are the ones that are referred to as decimal numbers. So if you look at this portion here, this line has been made deliberately thick. It's a special line. This line is what demarcates between the whole numbers and the fractions or the decimals. Is this thick line you see here that marks the boundary between whole numbers and fractions or decimal numbers. So see our unit from last week, this is familiar, tens is familiar, hundreds is familiar, and if you keep moving you will have thousand, tens of thousand, hundreds of thousand, just up like that. So but today our focus is going to be on what lies beyond units. We're still going to work with the numbers here, but then we're going to see how the numbers beyond unit blend with these whole numbers to form decimal numbers. Okay? So the first place position of numeric value that we have here is tenth. Okay, let's quickly refresh our memories on what we learned last week. Remember, we said that place value simply means the digits that a number has based on the position it occupies in a number. The position that the value that a digit has based on the position that it occupies in a number. Okay, so we looked at here, remember we looked at 26 and then 62. Right? So we found out that in the first number, which is 26, 6 here is simply 6 units because it's in the position of units. While the 2 here is 2 tens because in the position of tens, and 2 tens means what? 20. Now we reverse their positions. 2 came under units and 6 came under tens. When we did that, 2 became just 2 units, while 6 became 6 tens, meaning 60. Okay, so we find out that the position they occupy, these 2 digits occupied at every point in time, determine the value they have. 6 doesn't have a fixed value when it's combined with other digits. 2 doesn't have, no single digit has any fixed value when it's in combination with other digits. The value it has only depends on the position it's occupying. So here we see 6, because it's occupying the position of unit, is simply 6. But here that same 6, because it's occupying the position of tens, is 60. You see that? 2 here, because it's under unit, is simply 2 units. The same 2, because it's under tens, has become what? 2 tens, which is 20. I hope we are getting this. So just a quick reminder of what we explored last week, okay? To remind us of what place value is all about, so that as we continue looking at the place value of decimal numbers, we won't be confused or feel lost. Okay, so the first one we're going to look at here is the position of tens. Tens with a TH. Emphasis on that TH. Remember, if you look at the position, the one we looked at before, we had unit, we had tens, and we have hundreds. But the one we're looking at today is not tens, it is tens. Please take note. The next one is here, you have hundreds with an S, but in the decimal number, it is hundreds with a TH at the end. Now, there is a huge difference between these two. Between tens and tens, there is a huge difference. And between hundreds and hundreds, there is a huge difference. Now, what do I mean? When a number is in the tens position or a digit is in the tens position, it means that digit is multiplied by 10. Whatever digit is in the position of tens is multiplied by 10. But whatever digit is in the position of tens with the th at the end, it means you are dividing that number by 10. You see, it's a whole world of difference. So much difference. Any number in the position of tens for the whole number, which we considered last week, is multiplied by 10. Or any number in the position of tens with a th, which comes after the unit, is divided by 10. I hope this is not confusing. We're trying to make it as simple as possible. Okay, now when we are going towards the left, the next one here is hundreds, and when you're doing hundreds for the whole number, any number in the position of hundreds simply means multiplied by 100. Okay, while the number in the position of hundreds with a th means divided by 100. It goes on and on. The thousandth position means divided by 1000. Are we saying that? So whatever digit you have in the 10th position simply means you are dividing it by 10. And you know you can never have the same answer as when you multiply that same digit by 10. To the left, it is multiplied by 10, but the one to the right of the unit, it is divided by 10. If it's 100, it's divided by, okay, by 100, and then by divided by 1000. Okay, and if you look at the arrow I drew beneath here, it means as you move from the unit towards the right, the value of these numbers keep decreasing. Their values keep decreasing, reducing, going down. But as you move towards your left of this boundary, the value increases. And mind you, whatever you have on this right side of this boundary is less than whole. It's not a whole number. Okay, all the whole numbers you have are towards the left of this point. Please take note of that. Whatever you have on the side where you have all this th, it means divided by. So if it is 10th, divided by 10. If it is 100th, divided by 100. If it's 1000th, divided by 1000. But on this other side, you are multiplying, okay? By tens, you multiply by 10. Hundreds, you multiply by 100. Thousands, you multiply by 1000, okay? To get your values. I hope we are following. So please, we're going to consider some examples here to make this clearer for us. Okay, let's consider some examples that we have here. The first number that we have here is 12.54. 12.54. So permit me, I'm going to erase what we have here. Okay, I'm going to erase what we have here so that we can make room for what we need to do now. Or better still, let me see if I can move this up. Times 100. I hope you can see this. Times 10. Divided. This is times 1. Which is the same thing. This is divided by 10. Divided by 100. And divided by 1000. Okay? Okay. So at least we can use this portion at the bottom here. Hope it's not looking too rough. Okay, let's just manage, please. Okay, so what we have now is the first number here is 12.54. Now this is what I want you to know. This point here that I made the line very thick and I said it's very special is where your point will always sit. This is the point here. You see this round mark down here? That is your point. So your point must align with this point. So here we have a number 12.5 and 4. So if your point goes here, that means your 12 goes to the left and the 5 and 4 will go towards your right. So the way they are now, that is how you will arrange them here. So when you are, let's look towards the left first of all. Okay, towards the left, after your point, as you move towards the left, what is the first number there? It is 2. Sorry. The first number there is 2. And then the next number is 1. So the 2 is under unit and the 1 is under tens. Now remember, the point aligns with this. This is the point we have here, okay? So after the point to your right, what is the first digit? The first digit there is 5. And the next digit there is 4. So that is how you arrange your number in the place value chart. So if they ask you what is the value of this one, the value of this one is 10 because it's in the position of tens. 110 is 10. This 2 is in the position of unit, so it's just 2. It's still 2. Now this 5 is in the position of tens. So what is the value of this 5? The value of this 5 is 5 divided by 10. Is 5 divided by 10, which is half. The value of this 5 is half, which is the same thing as 0.5. The value is, this 5 here is 5 divided by 10, and that is the same thing as half, or 0.5. That's the value of this 5, it's 0.5, it's less than 1. And then what about the 4? What's the value of that 4? The value of that 4 is 4 hundredths. This is 5 tenths. This is 4 hundredths. Okay? And what does that mean? 4 divided by 100. And that is 0.04. That is the value of this 4 here. Okay? So, you may not be asked to, be solving. There is a way you can just write this and it will be so simple for you. Now I'm going to show you the trick. Okay, I'll show you the trick. If you are asked to write the value of this 5, you don't need to go into calculation like 5 over 10 and all of that. Just write this point. You see this line here, it represents your point. Just say 0.5. Finish. This 0.5 you have written is the same thing as 0.5. Now, if they ask you what is this number 4 here, remember again, you come to the point, you write point. There is a number before the 4, but you can't write that number. So you will put 0 there in the position of 5, which is before 4. You put your 0 there, then before you put your 4. Okay, that's 0.04. And remember, 0.04 is the same as 0.04. So if you can just arrange your number in the chart, it will help you to find out the position or the value of each of these numbers. So let's take the first one now and write out the values of all the digits that we have there. So for this number 1, you have that 1 is equal to 110, which is 10, right? So the 2 is equal to 2 units, which is what? Just 2. Are we following? This is just 2. And then the 5 that we have here is the same, is equal to 5 tenths. 5 tenths. And 5 tenths is what? 0.5. And the last one is 4. The value of 4 is 0.04. Sorry. It's 400th, first of all, before the 0.04. So the value of the 4 is 400th. with a TH, and that is 0.04. I hope this is clear. I hope we are seeing this. Let's go over that again. Look at the arrangement. You know the number is 12.54, and please take note of this. Any number or digits you see after this decimal point, they are not whole numbers, so you cannot call them the names of normal numbers. Okay, like this 5 and 4, you cannot call it 54. It's not 54, it's simply 54. Okay, it's 12.54, not 12.54. It's very wrong if you call it 54. So you simply call it the digits numbers. Just call the names of the digits rather. 54. That's what you call them. This is 154.3, 6.421. You can't say 6.421. That is wrong. 6.421. So let's go over this again. So we have 12.5 here. Now I said this point here always sits on this middle line here that demarcates between whole numbers and fractions. So once you align your point in the number to this, you can easily spread your numbers to the right and to the left of this mark. So here you put the point here and then look towards the left. What number is before the point? Is 2. That means 2 comes under unit. After 2, what is the next number? Is 1. That means 1 comes under tens, right? Now go back to your point again towards the right. After the point to the right, what is the first digit? It is 5. And after 5, what's the next digit? It is 4. Are we clear? So now they ask you, I'm going to do this again. I think it wasn't clear enough the first time I did it. So I'm going to repeat it. Now, if they ask you what are the values of the different digits that you have in this number 12.5. Now for the 1 is under tens, right? So your 1 is equal to, let me just roll this line so that you don't get confused. So 1 here is equal to 1 tens, right? That's 1 tens. And 1 10. And 1 10 is equal to what? 10. Then what is the value of the 2? 2 is under units. So 2 is equal to 2 units, and that is simply 2. Okay? And then you notice your point after 2. So you go to the number 5. Remember now your 5 is after the point. Okay? So your 5 is 5. What's the value? Tenths with a TH. Not tenths with an S. Tenths with a TH. And that is, what did I say? You write your point and you write 5. Remember, this middle line is a point. So that 5 is 0.5. And 0.5 is the same thing as 0.5. Now the number after 5 is 4. Okay? So you have 4 is equal to 400ths. 400ths with a TH at the end. Right? With a TH at the end. So look at it. You note your point. That is your point there. Okay? You have a digit before 4. So that digit becomes 0. And then you now write your 4. Okay? So your 400ths is 0.04. 0.04. The number before that 4, you will turn it to 0.04. And 0.04 is the same thing as 0.04. And the name of this number is, if you want us to name it, is 12.54. Okay, so that's how you arrange your digits. Now we're going to look at the second example. Okay, you can always pause your video to write down whatever you feel you need to write down. Okay, you can always pause your video, you can go back and all of that. So for the sake of space, we're going to erase this so that we can take the second example. So the second number here is 154.3. So that's the next number, 154.3. So let's create space here. Let's create some space. Okay, that should be okay. So what I will always advise is always use your point to mark how you arrange your number. That will always help you. So look at this point. This point is here, right? It's right in the middle here. So what is the number, let's say to the right of the point? The only number you have there is 3. So you just put it under the tens with a TH because it's to the right of the point. To the left of the point, what's the first number there? Is 4. So you have 4 under unit. After 4, you have 5. Have 5 under tens. And after 5, you have 1. That comes under hundreds. Okay? Now, let's find the value of each of the single digits of this number. So for your 1, we start with 1, okay? 1 is under what? 100. So 1 is 100. With a deal, and that means it is 100, 100. Now what is 5? 5 comes under 10, so it is 5 tens. And that means it is what? 50. Right? And what is 4? 4 comes under units. 4 units. And it's simply what? 4. It's simply 4. And then you come to 3. Remember, your 3 comes after the point. Okay? Your 3 comes after the point. So that means you will write it. That 3 is 0.3. And what? Oh, sorry. This is not the place for that. So your 3 comes under tenth, which is 3 tenths with a TH. And that means you write your 0.3 because it comes after the point. You must show the point. And I told you point, any number is the same as 0. That number. So these are the different values of these digits. Okay? So the last example we are going to look at is 6.421. That is our last example. Please, you need to go over this video again and again. The example we are going to look at is the number 6.421. 6.421. That's the next number we are going to look at. So for the number 6, we need to look for the value. Okay? So again, okay, let's get these numbers out of the way. Get this out of the way. Okay. Like I mentioned earlier, I'm saying again, you always look at the point. That is what helps you to properly arrange your numbers in the position, the numeric values positions. That's what helps you. So if you look at this point, what is the number to the left of this point? It is the number 6, and that comes here, right before the point. Because here, this is your point, and this is the number before the point. Then you now look at the positions to the right, the 3 positions to the right of the point. So the first digit you have there is 4, so this comes immediately after the point, followed by 2, and then you have your 1. Okay, so this is how you arrange the numbers in the place value chart. This is how you arrange the numbers in the place value chart. So for the 6, we're going to look at the value of the 6. So if you look at this, it's under unit. So 6 is 6 units, and that is simply 6. Now for the 4 comes under tenth. So you have 4 tenths. Okay? 4 tenths. You remember you have your point coming before the 4. You have your point coming before the 4, so you must indicate this point. Any number to the right of this point, you must show that point before you show the number. But to the left, you don't need the point, okay? Because these are whole numbers. But to this right, they are fractions. They are not whole numbers, and that is why it's important you always show the point. So you have 0.4, and I mentioned before, point any digit is the same as 0. That digit. So the value of that 4 is 0.4. Now the next digit here is 2, and 2 comes under hundredths with a TH. Hundredths. and that means that 2 is divided by 100. But you don't need to worry yourself about that calculation. It's enough. Just ask, I have my point here, put your point there, and then you have a number, a digit before the 2. So that digit's position, you will put 0 there. Then you write your 2. Remember, because it's 2 we are looking at. So the number 2 is 0.02, and 0.02 is the same thing as 0.02. So that's the value of the 2 there, 0.02. And the last digit we have here is 1, and that one is 1,000. It's in the thousandth position with a TH. 1,000. And that is, again, you have to use your point. So that point comes here. Then you have a number which is not the one we are looking at, so you write that down as 0. After that digit 4, you have another digit which is 2. Write it as 0 before you get to the one we are looking at, which is 1. So this number is 0.001, and it's the same thing as 0.001. So that is the value of this number, 0.001. So please don't feel like this is so. There's nothing difficult here. The important thing is, if you can just try to draw this your place value chart, it's going to simplify everything for you. It will make everything very easy. Yes, as you go towards the left, you are multiplying by multiples of 10. As you go towards the right, you are dividing by multiples of 10. Okay, so as you go towards the right, the numbers are going down, they are decreasing. But as you go towards the left, they are increasing. Now, how do you find the numbers, the values of the digits that you have after the point? How do you find their values? Just simply mark the point. Mark the point. Any number that comes after the point must bear that mark, point, whatever it is. You must use that point for every number that comes after this point, this middle mark, this demarcation point. Every number that comes to the right of it must have. So if it's the first number here, just write 0.4. That's the answer. And 0.4 is the same as 0.4. If it is these two, what will happen is write your point, but you know there is a number before the 2. So that number, you will just convert it to 0 and you write 0.02. And 0.02 is the same as 0.02. And lastly, you have 1 there. So how do you take care of that? You write point. This 4 becomes 0, this 2 becomes 0, and you write your 1, 0.001. And 0.001 is the same as 0.001. I hope it's clear. I hope we have learned something. Please remember, this place value chart is very, very necessary. I will encourage you to make sure you draw it in your notes. Have it there because it will help you. On your own, you may not be able to easily say, okay, this is 0.4, 0. But if you arrange it like this, you can easily tell. It will help you. Just take note of the point and then count the number of digits you have before you get to that digit. Each of them becomes 0, and then you write the digits. So you will have your correct place value and value as well. So for the values of 4, for instance, it is 4/10, and we wrote it. And then the value of the 4 itself is 0.4. So these are the place values in the middle, and these are the actual values that we wrote out. I hope it is clear. 6 units, 4/10, 200, 1,000. Those are the place values. Then the actual numbers we wrote out are the values of the different digits. Okay, I hope this is clear enough. Please, you need to go over this again, and for further questions or queries, you can always the platform, the WhatsApp page is there, and also the comment section below can be used to ask questions. Okay, we get back to you. So the next sub concept we're going to explore under place value is comparing and ordering numbers. Yeah, I say it's under place value or it's related to place value because at the end of the day, everything comes back to the value the different digits have. In order for you to be able to compare two numbers, you have to look at the different digits that form those numbers and the position that they occupy, because that's how you will know their values in order to determine which one is bigger or which one is smaller. Okay, and even in ordinary numbers, you are either ordering from the smallest, arranging numbers from the smallest to the biggest, or you are arranging from the biggest to the smallest. So whichever the case is, you always need a deep understanding and application of your place value to be able to determine the size or the value of a number, or the value of numbers, in order to be able to compare and order them. So again, you see place value chart here. I'm writing this because it's something that will be very helpful as we are exploring this anything number. Okay, this place value chart is very, very valuable. That's why I'll keep referring to this. Okay, I'll keep referring to this. Now, if you are given two numbers, for instance, how do you know which one is bigger, especially if they have similar digits? How will you know? For instance, let's take example. You have 11011. That is a number, right? 1, 2, 3. You put your comma here. And you have another 0, 10111. And then you have your comma here. If you look at this number, they are both made up of two digits and the same digits at that. And if you see the arrangement, it looks somehow. How do you tell? How can you say this is bigger than this or this is smaller than this? It brings us back to this place value thing. So for the first one, we're going to arrange it. So the first one is here, followed. Remember, we always work from unit backwards towards the left. You have the next one, then you have 0 here. You have 1 here and you have 1 here. Don't mind me that this is rough, okay? But I know you know these tens, these units, tens, hundreds, thousands, tens of thousands, or 10,000s and 100,000s or hundreds of thousands. Now for the second number, you have, let's start again from the unit. You have 1 here, you have 1 in tens, you have 1 in 100, you have 0 in 1,000, and you have 1 in tens of thousands or in 10,000s. Now let's look at these two numbers. Both of them have the same value in tens of thousands. So you cannot say which is bigger or which is smaller. But let's move forward. If you look at the next position here, you find out that the first number has 1 in the position of 1,000, but the second number is 0. So automatically from that place, you can tell that the number up here is bigger than the number down, because this number has no value, it has nothing in the 1,000 position, whereas the first one has 1,000. So this number up here it has 2 digits in the 1,000 family, 11,011. It doesn't have a number or a digit in the 100 position, while the second one is 10,111. Even though this one has no digit here and the second one has a digit, we already know that 1,000 is bigger than 100. So for the fact that this first number has a digit in the 1,000 position and the second one does not, this first number is larger than the second number. Either you use this place value chart, or you can also use this. You see what I wrote out here? You have unit, tens, 100, 1,000, tens of thousands, and hundreds of thousands. You can also use that. You arrange these numbers under them, you're going to arrive at the same thing. So let's try that. So here you have, let's take the first number. The first number is 1, 1, 0, 1, 1. And the second number is 1, 1, 1, 0, 1. I hope you're seeing the arrangement. So if you look at them, both of them have the same number, the same digit in the tens of thousands. So you can't determine which is bigger or smaller. But then when you move to the position of 1,000, you have that the first number has 1 there, while the second number has 0 there. So already that tells us that this first number is bigger, because 1,000 is bigger than 100. Because you move forward, you find that this first number doesn't have any digit in the position of 100, but the other one has. But that doesn't matter anymore, because we know that 1,000 is bigger than 100. For the fact that this first one has a digit here and this one has none, it already shows this first one is larger. Even if it's not 0, if the digit here is bigger than the digit here, this is already bigger. Okay, so just start from the far end to your left to consider which is larger than the other, or which is smaller than the other. This is always where you start, from this end, because that end, the value of the numbers in that end, they are larger. From the left end, they are larger. So when you're considering which is bigger, which is smaller, you always start from this left end and you walk towards the right. So any position you get to and you see differences, you always check that, and from there you should be able to get your number as to which is bigger and which is smaller. Now let's consider another example of comparing numbers, and doing that using the place value chart, or arranging these units, units that show values of numbers. Whichever one you choose to use, once you have a good understanding of it, you're definitely going to be able to properly order your number or compare your numbers. So let's write out the numbers we have here. So we have 3. The first number is, sorry, I shouldn't arrange from there, it's very wrong. You start arranging from the unit, and so the last number here to the right is 6, 4, 8, 6, 5, and 3. And then for the second number, you have 0, 6, 4, 1, 5, 3. I hope you know why I'm arranging from here. Arranging from the left towards the right will give you may get it wrong. So it's always safer you start arranging from the unit. I know I mentioned it in our last video. You always arrange from the unit end and work backwards towards the left. That way you can never miss your arrangement. You will always get it right. So let's look at these two numbers and try to compare them. Okay, let's try to compare them. So if you look at the first, remember, when you are writing them down, you work from the unit backwards. Okay, but when it is time to check, to compare, and to order, to know which is bigger, which is smaller, you always start from the largest end. You start from the end with the largest value. Okay, and that is the extreme left side. So you start from there to compare. Okay, you can't start from this side. This doesn't hold weight. It doesn't carry, it's not significant when it comes to deciding. You always start from this left end. So here, if we look at the position of hundreds of thousands, both numbers are the same. They are both equal. 3 is here, 3 is here. So you cannot tell which is larger. Okay, so you have 3, you have 3. We go to the position of tens of thousands. We also have the same numbers, 5 and 5. You can say which is bigger. Okay, so the next one we are going to look at is the position of thousands. And the position of thousand here, for the first number, you have that the digit there is 6, while the second number has the digit 1. And looking at the two digits, 6 is obviously bigger than 1. You go no further. Once you have found this, you don't bother stressing with what is remaining on the other side. Once you have found 1 in a particular spot, in a particular position that shows value where one number is bigger than the other, then you know that number is definitely larger. Remember, the first digits, the first 2 digits are the same, so you can't use those to decide. But now we have found a position where one of the numbers has a larger digit than the other number, and that position is the position of thousands. In the position of thousands, the first number has a larger digit, which is 6, than the second number, which has a digit 1. So that means that the first number, which is 356,846, is larger than 351,460. Okay, now we're going to try and name the first number. What is that number? You find out that you have the 3 numbers here in the family of 1,000. Yes, I always call it the family of 1,000. So how do you name it? What you simply do is call the name of these 3 digits. What do you call these 3 digits when they are together? 356. This is 356. And what is the family name? 1,000. Because the 3 of them are in the family of 1,000. 356,000. Look at it. This is 1,000, this tens of 1,000, this 100 of 1,000. They are all in thousands. So you have 356,846. 46. Okay, should we try writing in words? I don't think it's necessary. So you have that this number 356,846 is larger than 351,460. And that brings us to the very, very significant symbol that we use to show numbers when we are comparing them. Now look at the marks. I will just quickly show us the marks and then give us some things to work on, some numbers to work on. So you have this. I hope it's clear enough. Can we see that? This is one of them. This is the second one. And this is the third one. Now, how do this work? We always try to remind ourselves using the crocodile, the mouth of the crocodile, as something that will help us to remember how this works. Otherwise, it could be very tricky, But once you understand that the crocodile, why do we say the crocodile? If you look at this shape, it looks like the mouth of the crocodile when it's opened. Okay? So we say that the greedy crocodile always goes for the larger number. The greedy crocodile always goes for the larger number. So when you are comparing two numbers, the mouth of the crocodile will always open to the bigger number. So see the one we worked on here, for instance, this 356,846. Remember, we said that is the larger number because we found that out from here. So see the way we use the symbol. The mouth of the crocodile is open to the big number. It wants to eat the big one. It's greedy. That's why we say it's greedy, because it always goes for the larger number. Okay? And the closed end is towards the smaller number. That's how we use it. Okay? So if your smaller number is towards the left, you use this symbol. You see, if your smaller number is towards your left, that means the closed mouth will be towards your left, while the open mouth will be towards your right. But if you put your larger number towards the left, that means you use this second symbol that has its mouth open towards the big number and closed towards the small number. And then this last symbol you see here is the symbol of equal to. Equal to. There are times you could be given two numbers that have the same value. And when you arrange them in this place value chart, you will just find out that they are the same at every point. Every numeric positional value is the same. So in such a case, you simply use this symbol, that this number is equal to that number. So these are the three important numbers that are used when comparing numbers. Now, I don't want to write larger than, smaller than for these two numbers, because why am I saying that? They are just, when you flip one, you get the other. They are the same. The value they carry just depends on where you are facing them, which position you are turning them to face. If this one, like this one, the mouth is open to the right, that means the bigger number has to be to the right. You can flip it or write this one, the bigger number is at the left. It just depends on where you put your number. But the basic thing, the important thing for you to note is the bigger number always stays at the position where the mouth is open to. The part where it seems like the crocodile mouth is open to, that is where your bigger number stays. And the part that is closed is where the smaller number stays. Okay, so I'm going to give you some work to practice with, okay, so that you'll get a hang of this. So right here you have a few problems, to just something very small actually, just for you to check how much of this concept you understand. So it's just for you to practice with. The first one here says, write out the place values and the values of these numbers. What do we mean by place values? Remember when we did this, when we did something like this earlier for the decimal place values, we would say this number, for instance, is 2/10, 2/100. That's the positional value, that's the place value. But the value of the number itself would be like 0.02 or 0.002. You remember that? So that's what you're expected to do for numbers A and B, 1A and B. Then number 2 says compare the following numbers. So for A, you have 23462 and 23642. I'm deliberately not calling the real names. I need you to figure that out. Now when you compare, you can also write out their the names in the written form, okay, word form. And the second one here is 600451 and 598746. So you try your hands on this and see how much of this concept you understand. If you have any queries, if you have any challenges, always feel free to put down your queries in the comment section below. And we beg you as usual to try and share this video, like this video, and if you haven't subscribed to our channel, we plead with you to please subscribe to our channels. Okay, hope to see you next week. Stay blessed and stay safe.